All right. Good morning, everybody. Welcome to our first video lesson. Now, the first lesson is on solid shapes with a uniform cross section. And remember, this is what learning on demand. So feel free to stop the video at any time. And if you need to write notes or if you need to see something again, just rewind it or whatever, and look at it in a time frame that is what comfortable to you. All right, so let's just read some information. We'll look at some information in general, and then as we progress in the lesson, we'll see how the entire thing ties in. Now, first of all, we'll look at the word cross section. A cross section is the area of a solid that is exposed when the solid is cut. All right, so if you're a solid and you cut the solid, the surface that is exposed is called the cross section. The word uniform as it's used here means so what the same. And here's how we start out. We start out by saying that the volume of all solid shapes with a uniform cross section is given by the formula V is equal to A times H. So we'll look into that and see exactly what that means. But A in this formula stands for area of the uniform cross section, and H stands for the height. All right, let's give you some more formulae and interpretation of it. All right, the total surface area of a closed solid with a uniform cross section is given by the formula TSA, which is equal to PH plus 2A. Now, P in this formula stands for the perimeter of the uniform cross section, and H stands for the height of the solid. A stands for the area of the uniform cross section. pH calculates the area of the sides of the solids, and 2A the area of the two ends. Again, this will sort of like have more meaning to you. When we actually get into the thing. All right. All right. Let's have a look at examples of solid shapes with a uniform cross section, and sort of see if we can understand exactly why these are solid shapes with a uniform cross section. The first one we want to look at is the cube. When you think about a cube, we can think about a die. A die, or Jamaicans normally say dice. All right, but let me try and sketch an example. All right, if you're going to sketch a cube, first thing you'll try and do is that you'll try and draw a square. All right, then you try and draw another square identical to that one, identical to this square. Let's copy this. All right, I might be able to copy and paste. You might not be able to do that. Then you're going to put this square 1/4 in the first square. So if you're going to draw your cube, this is how you would start out. You start out by drawing a square, and then you draw a second square identical to the first square, but the second square must be drawn 1/4 into the first square. Then you're going to connect corresponding ends. So let us connect corresponding ends. All right. Now this shape is called a cube. It's called a cube. All right. I'm going to sort of let mine look a little bit better. When you are doing it, I guess you can use rulers. All right. So this is an example of a cube. Now the cube is a solid shape with a uniform square cross section. All right. Um, so what do I mean by that? For the cube, the shape at the bottom here, that's a section that I'm shading. The shape at the bottom here is a square. The shape at the top is also a square, and it's actually the same square. So there's that word again, the word same, which as I said means what? Uniform. Now if I take a knife and maybe like slice the square in the middle, if I like slice the square in the middle, for example, I probably get another what? Square. I slice the cube in the middle, I get another what? Square. So for this shape, the shape at the bottom is a what? Is a square. The shape at the top is the what? Same what? Square. And if I cut it in the middle, the shape that is exposed, which is the cross section, will also be a square. All right. So the cube is an example of a solid shape with a uniform cross section. Or we can say that the cube is a solid shape with a uniform square cross section. So, all right, we'll also talk about the volume. We said that the volume is equal to A times H. For this shape here, the cube, this side here would be the length, this side here would be the width, and this side here would be the height. Now, A in the formula we said we're looking at volume of a cube. Volume of a cube. And for the cube, the length is equal to the width and is equal to the height. So if you want, you could just call all of them what? You could just call all of them L. Alright? So for the cube, the volume is equal to the area of the cross section times the height. And as you can all see, the cross section here, that's at the bottom here, the cross section or the uniform cross section is a square. So the area of a square is length. The area of the square is length times what? Length. Now times the height. But for the cube, the length is equal to the width, which is also equal to the height. So length, so the area of the base, the area of the cross section, which is length times length, multiplied by the height, which is also what? Length. So the volume of a cube is what? Length cube. All right. We later on we can look at more at the cross section, at the total surface area. All right. A cuboid. Another name for a cuboid is the rectangular prism. All right. Let's start to do a sketch. You guys have to learn how to do this sketch, because it might be necessary in an exam. So if I'm drawing a cuboid, I'd start out by drawing a rectangle. Then I would draw an identical rectangle. I put a little bit above it, sort of something like this. Then connect corresponding ends. Use your pencil and your ruler, and you connect corresponding ends. Alright, so this is an example of a cuboid. It's a solid shape with a uniform rectangular cross section. Alright, let me sort of like make it nicer or neater. Alright, so this is my example of my cuboid. Alright, and the cuboid has a uniform rectangular cross section. So this is the rectangular cross section. This is length, this is width, and this is the height. Now, volume of all solid shape with a uniform cross section is given by this formula. V is equal to A times H, where A is the what? Area of the uniform cross section and H is the height. But in this case, that is a cuboid, the uniform cross section is a rectangle. So this is the uniform cross section that is shaded right here. All right. So that is my uniform cross section, and it is a rectangle. So A here would be length times what? Width times height. The volume of a cuboid is length multiplied by width multiplied by height. All right. So again, the volume of all solid shape with a uniform cross section is given by the formula V is equal to A times H. A in the formula stands for the area of the uniform cross section, and H is the height. So we can say that the cuboid is a solid shape with a uniform rectangular cross section. What do I mean by that? It means that the shape at the bottom is a rectangle, the shape at the top is a rectangle, and if I cut it in the middle, the shape that will be exposed will also be the same rectangle. All right, let's have a look at the cylinder. All right, and as I said, you need to be able to what? To make sketches of these if necessary. All right, so for this, you draw a circle at the bottom, or a circle at the top, circle at the bottom, and then you would connect the ends. So I'm connecting the ends. All right, so a cylinder would look something like this. All right, I'm sort of going to make mine a little neater because I can. All right. So this is an example of a cylinder. And a cylinder is a solid shape with a uniform circular cross section. Circle at the bottom, same circle at the top, and if I cut it in the middle, the same circle will also be exposed. Now, the volume of all solid shape with a uniform cross section is given by the formula V is equal to A times H. Again, A in this formula stands for the area of the uniform cross section. So again, the uniform cross section is a circle. All right, I'm shading it here. All right, and the area of a circle is what? Pi r square times what? The height. So the volume of a cylinder is given by the formula V is equal to pi r square times the height. All right, we can have a look at another example of a solid shape with a uniform cross section, the wedge. Another name for the wedge is the triangular prism. All right, so I sort of like give you some ideas to how this could possibly look. All right, just start out by drawing a right angle triangle. All right, you should use your rulers. Try and draw another right angle triangle identical to the first, but maybe just a little higher, and then connect corresponding ends. All right, so this is what a wedge would look like. And another name for a wedge is a triangular prism. All right, let's try and make it a little neater. All right, so that's it. All right, I think I want to go back here just a little. Here for the cylinder, this length here is the height. All right. You can note in all cases the in all cases the height and the uniform cross section are always at right angles to each other. So if the uniform cross section is what is horizontal, the height is vertical. All right. In the case here with the wedge, The uniform cross section is this triangle. The uniform cross section is this triangle, the same triangle at the other end. The uniform cross section is the triangle. So this is the uniform cross section. Here is the height. This length here would be the height. And again, volume would be equal to A times H. Alright. Area here would be the A here would be the area of the uniform cross section, which is the area of the triangle. And the area of a triangle is what? Half base times height. So this height here is the height of the triangle times multiply now by the height of the prism. And the height here is the height of the prism. This is the height of the triangle. All right. So again, the volume of all solid shape with a uniform cross section is given by the formula V is equal to A times H. All right. And again, remember, the video might be going at a particular pace. It's not necessarily mean that you must move at that pace. You can simply, one thing you can simply do is stop the video at any time. If it's necessary for you to stop it, stop the video at any time. Record your notes. Rewind it. Play it again if you didn't hear something properly. It's up to you. All right. All right, let's have a look at a simple example. In this example, we're going to calculate the volume and the TSA of the following closed shape. All right, we're going to calculate the volume and the total surface area. First of all, the shape that we're looking at is a cuboid. All right, it's a solid shape with a uniform rectangular cross section. All right, so this is my rectangular cross section. The length is 15, the width is 8, and the height of the cuboid is H. So V is equal to what? A times what? H. A in the formula stands for the area of the cross section, and H stands for the height. All right. For a cuboid, the cross section is a rectangle. So A in the formula is length multiplied by width. And then now to get the volume, you multiply by the height. Therefore, volume is equal to 15 times 8 times 7. The volume would be equal to 840 centimeters cube. Why centimeter cube? Because it is what? Centimeter times centimeter times centimeter gives you centimeter cube. The length is 15 centimeter, the width is 8 centimeters, and the height is 7 centimeters. Centimeter times centimeter times centimeter gives you centimeter cube. Now let's talk about the total surface area. All right, the total surface area using a formula. So let's go for the formula. Total surface area is equal to PH plus 2A. All right, what do they mean by total surface area? First of all, we're told that this is a closed solid. This is a closed cuboid, or the cuboid is a closed shape. What that simply means is that that this shape has all its sides, which would be like sort of like different from, let's say, maybe a container. The container would probably have an opening, maybe like a fish tank. A fish tank would have what? Let's say 4 sides and a bottom, but it would not have a top. So a fish tank would not be considered to be a closed shape. But this solid is a closed shape. So it has all 6 surfaces. There are 4 sides, and there are what? There's the top and there's the bottom. So the total surface area gives you the sum of the area of all 6 surfaces. All right. P in the formula stands for the perimeter of the uniform cross section, which in this case would be what? 15 times plus 15 plus 8 plus 8. The perimeter is a rectangle. Sorry, the uniform cross section is a rectangle. All right, so this is going to be what? 30 plus 16. This is 46 centimeters. Therefore, the total surface area would be equal to P, which is 46, times the height, which is 7, plus 2 times A. Now, A in this formula is the area of the uniform cross-section. The uniform cross-section is a rectangle. So the area would be 2 times 15 times 8. How do you find the area of a rectangle? It's length times width. So let's work this out. 46 times 7 is equal to 322 plus 2 times 2 times 15 times 8 is 240. Let's add these together. Plus 322. The total surface area is 562 centimeters squared. The total surface area is 562 centimeters squared. Ladies and gentlemen, the volume of all solid shapes with a uniform cross section is given by the formula V is equal to A times H, and the total surface area of all solids with a uniform cross section is given by the formula TSA is equal to PH plus 2A. So what makes a solid a shape with a uniform cross section? It's simple. If the shape throughout the length of the solid is the same, we say that the shape is a solid shape with a uniform cross section. In the case of a cuboid, throughout the length of the solid, you'll always have a what? A rectangle. Rectangle at the bottom, rectangle if you cut it to the middle, rectangle at the top. In the case of the cylinder, it's a circle at the bottom, the same circle at the top. If you cut it in the middle, it will be the what? The same circle. And the volume, V is equal to A times H. The total surface area is TSA is equal to PH plus 2A. Sir, do I have to remember these formulas? Yes, you have to. Why? Because they're not given on your formula sheet. All right, let's have a look at a second example. Ooh. All right, this actually is a continuation of one. All right, but to actually finish it, but no, let's do something else with it. A while ago, I showed you how to find the total surface area using a formula. Now, let us look at finding the total surface area. Let's look at finding the total surface area using an intuitive approach. What I'm going to do is I'm going to find the area of all 6 surfaces and add them together. All right. First of all, the solid has 4 sides. The solid has 4 sides. I could say that this is 1, 2 here at the front, one here, side here, and one here. There are four sides. All right. All right. Let's put in some numbers instead. Let's say that this is side 1, side 2 here at the front, side 3 here at the side, and side 4 at the back. All right. You should be able to recognize that sides 1 and 3 are identical, and sides 2 and 4 are identical. And then of course there is the what? There's the top and there's the bottom. All right. So um, side 1, the area A is equal to length times width. Remember, side 1 is over here at side 1. Um, the length, I'm seeing the length as what? As 8, same as the side out here. The length is 8, and the width of side 1, which is a rectangle, is 7, which is equal to the height. So it is what? 8 times 7, which is 56, and that is centimeters square. Side 2 is equal to, sorry, so the area of side 2 would be equal to the length. Side 2 is at the front, where the length is 15, and the height is still, and the width is still what? 7. So it is what? 15 times what? 7. All right. So so this is not, we're not looking at the entire shape, we're looking at it what? One surface at a time. All right. So we have what? 15 times 7 is 105. So it's 105 centimeters square. Please remember that that sides 2 and 4 are identical. So and sides 1 and 3 are identical. So I wouldn't need to do I wouldn't need to do side I wouldn't need to do side 3 because I already did side 1, and I wouldn't need to do side 4 because I already did side 2. All right, let's talk about the area of the top. Area of top and the bottom. All right, the area, the top is the same as the bottom, so the area is what? 15 times 8. So that is what? 120 centimeters square. So the total surface area, and if we are correct, the answer that we get should be equal to the answer that we get from using the formula, which is 562. So the total surface area would now be what? The area of all 6 sides, which would be 56 plus 56. Why? That's sides 1 and side 3 plus 105 plus 105, and that's sides 2 and 4 plus 120 plus 120, and that's the area of the what? The top and the bottom. So let's add them all together. 56 plus 56 is 112. So it's 112 plus 105 plus 105 is 210. 120 plus 120 is 240. So our answer is 562 centimeters square. All right. So this approach is a more intuitive approach. In this approach, what I did is I found the area of all 6 surfaces and add them together to get the total surface area. All right. Here we're going to do the same thing. for a cylinder. All right. So the first thing we're asked to find is we're asked to find the volume. Again, the cylinder is an example of a solid shape with a uniform cross section. And for this cylinder, the radius of the uniform cross section of the circular cross section is 7, and the height of the cylinder is 10. Volume is equal to A times H. A in the formula is what? Pi r squared times H. All right, so everybody should know that pi is approximately equal to 22 over 7 times the radius, which is what? 7 times what? 7 again, because it's radius square, times the height, which is 10. All right, let's cancel the 7. So my answer is going to be 22 times 7, which is 154, times 10. The answer is 1,540 centimeters cube. All right. So the unit of volume is millimeters cube, centimeters cube, meter cube, or the kilometer cube. Why cube? Basically, because whenever you find volume, it always involves multiplying 3 lengths of the same unit. All right, so we did the volume. Let's have a look at the total surface area. Now, the total surface area of a solid shape, of all solid shape with a uniform cross section, is given by the formula TSA is equal to PH plus 2A. P is the perimeter of the cross section, H is the height of the solid, and 2A is the area of the what? The two ends, the area of the top and the area of the bottom. All right. For a circle, the cross section, for the cylinder, the cross section is a circle. So I'm shading the cross section here. And the perimeter of another name for the perimeter of a circle is the circumference. So P is what? 2 pi r and times H plus what? 2A. Remember, A is the area of the uniform cross section, which is 2 pi r squared. All right. So this is 2 times 22 over 7 times 7 times the height, which is what? 10, plus 2 times 22 over 7 times 7 times 7. All right, let's do some work here. This is 440 plus, cancels you here and here. This is 7 times 22 is 154. 154 times 2 is 308. So the answer is 740. All right, that's 748 centimeters square. All right. So remember that you can pause this video at any time. You can think about it. You can interact with your friends. Over the entire thing, to ensure that you understand it. Go over it if necessary. You can view the video, anytime you want. So here's some additional information. Maybe some stuff I probably should have said at the front but didn't. Some of it anyway. So some additional information, things which are important. A liquid takes the shape of its container. So That fact is going to come in play soon. You're going to see the importance of it. A liquid takes the shape of its container. So, for example, water has no natural shape. If you pour water into a cylindrical cup, the water becomes a cylinder. If you pour water into a cuboid container, the water becomes a cuboid. So a liquid takes the shape of its container. The unit of amount or volume of liquid is the liter. So since liter is measuring liquid volume, it means that there must be some connection now with metric volume, or volume of, let's say, a solid shape with a uniform cross section. Well, 1 liter is equal to 1,000 centimeters cube. 1 liter is equal to 1,000 centimeters cube. Now, the volume of a solid is a measure of the amount of space the solid occupies. So I didn't say that initially, but it's important. The volume of a solid is a measure of the amount of space a solid occupies. So whenever you're measuring volume, what you're measuring is how much space something is occupying. A prism, I used the word prism earlier to describe the cuboid and the cube and the wedge. The cuboid, the cube, and the wedge. A prism is a solid shape with a uniform cross section, and rectangular sides. So the solid shape with a uniform cross section that has rectangular sides is referred to as a prism. All right. Here's a question. Here's a question from your workbook. It's question 3 on page 142. What I advise that you do is I advise that you pause the video, attempt the question for yourself first, and then go back and view. Then go back to the video and view it now to see if what you did is correct. If you find that you're having issues and not understanding fully, maybe you can play the video a little. When you get the understanding that you need, stop. You understand? But always ensure that you attempt the question on your own. Mathematics is a spectator sport. You can't do it. You can't say you can do it unless you actually do it. All right. Here's what the question says. It says the diagram above, not drawn to scale, shows a water tank in the shape of a right prism. AB is 25 centimeters. AD is 40 centimeters, and the length of the tank is 1.2 meters. Calculate the volume in centimeters cube of the tank. All right, first of all, we can clearly see that this tank is a cuboid. There's a little catch to the question. There are 2 different units. All right, the unit here is meters, whereas the other units in the question are what? Centimeters. All right, so the first thing is that you cannot work with 2 different units, and you must convert the meter to centimeter. All right, so 1 meter is equal to 100 centimeters. So 1.2 meters is equal to 120 centimeters. So that's the first thing we have to do. Volume is equal to length times width times height. The length is 120, the width is 25, and the height is 40. So the volume of the solid is 120 times 25 times 40. We have 120,000 centimeters cube. So the volume of the tank is 120,000 centimeters cube. All right. The next thing they're asking us to do is to calculate the depth of water in the tank when it contains 45 liters of water. All right. So let's try and get an appreciation of 45 liters. Remember earlier we said that 1 liter is equal to 1,000 centimeters cube. All right, we said that earlier. 1 liter is equal to 1,000 centimeters cube. Therefore, 45 liters would be equal to 45,000 centimeters cube. So, what is the first thing I am observing? I am observing that the tank is not full because the space or the capacity of the tank is 120,000 centimeters cube, and the amount of liquid water that was poured into the tank is only what? 45,000 centimeters cube. And what we're being asked is to determine the depth of water in the tank. So let's sort of illustrate what's sort of happening. All right, somebody pour some water in this tank. All right, and this dimension here, height, would sort of like be the height of water in the tank or the depth of water in the tank. All right. All right, let's see. Now, first of all, this question is a very popular question in CXC. Once you go through the homework, I'm sure you're going to see the question over and over and over again. All right. So it's something that we need to get used to or get accustomed to. All right. So let's have a look at the water. So we're looking entirely at the water now. And if you might remember, we said that a liquid takes the shape of its container. A liquid takes the shape of its container. So the container here is a cuboid. Therefore, the water in the tank is also a cuboid. The length, sorry, the width of the tank is 25. Therefore, the width of the what? The water in the tank is also what? 25. The length of the tank is 120 centimeters. So the length of the water in the tank is also 120 centimeters. The thing that is different now between the water and the tank is the height. The height of the tank is what? 40, and the height of the water in the tank is unknown. All right, so that height we're going to call what? H. But here's what we know. The volume of water in the tank is 45,000 centimeters. All right, so let's calculate the volume of the water. The volume of the water is what? Length times width times height, and that is equal to 45,000. Why length times width times height? Why? Remember, the liquid takes the shape of its container. The container is cuboid, so the water in the container is also a cuboid. All right. The volume of a cuboid is length multiplied by width multiplied by height. So the volume of the liquid in the container, 45,000 centimeters cube, is also length multiplied by width multiplied by height. Let's put in what we know. This is 120 times 25. And what we don't know is the height. And this is 45,000. All right. 25 times 25 times 120. Let's find out what that is. 120 times 25. That's 3,000. So 3,000 H is equal to 45,000. Divide both sides by 3,000. The height of water in the tank is 15 centimeters. All right. So we're sort of not really surprised with this answer. And the reason we're not surprised about this answer is because we sort of, for starters, the tank have a capacity of 120,000 centimeters cube, and the amount of liquid in the tank is what? 45,000, which is less than half. Half of the tank, half of the tank would be 20 centimeters deep, and since this is less than half, the depth of water in the tank is less than 20 centimeters. Again, play the question over. Do the question by yourself over. If you didn't quite get it, do it over. Understand? Rewind the video, play it again to ensure that you understand it. I mean, it's up to you. All right, let's have a look at this at a second question. All right, the question says, the diagram above, not drawn to scale, shows a wooden prism of length 25 centimeters. The cross section ABCD is a trapezium with AB parallel to what? CD, and the angle at A is what? 90 degrees. AB is 12 centimeter, BC is 5 centimeter, CD is 8 centimeter, and AD is 3 centimeters. We're to calculate I, the area in centimeters square of the cross section ABCD. All right, so first of all, the cross section that we're talking about is this trapezoidal cross section. All right. So everybody should remember the area of a trapezium is equal to a half A plus B times H. So A and B in the formula are the lengths of the parallel sides, which in this case are what? 8 and 12. So it's a half 8 plus 12 times the height of the prism, which is 3. So the volume here would be a half of 20 times 3. A half of 20 is 10. 10 times 3 would be 30 centimeters square. So the area of the trapezium is 30 centimeters square. All right, what next? The second thing we're asked to do is to calculate the volume in centimeters square of the prism. So here's what I'm saying. And this is something that I've been saying all along. The volume of all solid shape with a uniform cross section is given by the formula V is equal to A times H. Please bear in mind that the prism here, the trapezoidal prism, is an example of a solid shape with a uniform cross section. The shape at this end is a trapezoid. The shape at the other end is also a trapezoid. If I cut it like slices going across from one end to the next, every single time I cut, the shape that will be exposed would be a trapezium. All right. So we already calculated the area of the cross section. It is what? 30, and the height is what? 25. So let's get 30 times 25. All right. The volume is 750 centimeters cube. Remember, the unit of area is centimeters square. The unit of volume is centimeters cube. Now, the last thing we need to do is to calculate the total surface area in centimeters square of the prism. All right. Using the formula, the total surface area. If we wanted to, we could also use, for this one, we could use an intuitive approach. The total surface area is equal to what? pH plus 2a. P is the perimeter of the cross section, which is what? 3 plus 12 plus 5 plus 8. So this is 28 centimeters. So the total surface area would be equal to 28 times the height, which is 25, plus 2 times the area of the cross section, which is 30. So this is 700 and this is 60. The total surface area is 760 and this is centimeters square. So the unit of area again is centimeters square. The unit of volume is centimeters cube. All right. All right. So the last thing I want to tell you, just again some additional information that I'm quite sure you'll probably come across. This shape here is a sphere, and a sphere is like a ball. So if you think about a sphere, think about a ball. So the Earth is sometimes described as a sphere. A ball, an orange, those are examples of a sphere. The total surface area of a sphere is 4 pi r squared. An easy way to remember it is to say 4 times the area of a circle with the same radius. And the volume of a sphere is 4 over 3 pi r cubed. Now, a hemisphere is a half of a sphere. So a half of a sphere is called a hemisphere. All right, so largely that's it for this topic. So I'm going to either post or send a video, and also I will let you know what the homework is via WhatsApp.